Good day, folks. Welcome to my YouTube channel. If you're new here, don't forget to subscribe, like my videos, watch my videos till the end. Let the ads play till the end. Do not skip them. Thank you so much, guys, for your support. Let's cut the chase. An electrolytic cell P, this shown below, is used to purify an impure copper sample for use of electrical wires. So the purpose of this purifying this impure copper, it's for the copper is used for electrical conductivity, so it's for improving the quality of the copper, the quality of the conductivity of the copper, because the copper it's used for electrical conductivity. Copper chloride solution is used as an electrolyte. Electrode B contains 95.7% of copper by mass. So this electrode bead has 95.7 by mass. This simply means that this is an impure sample, and always an impure is the anode, which is going to be positive, and this one, that means it's the cathode, right? And it's negative. That means that this is the pure copper, this is the pure, right? So here, what is going to happen, this impure that has impurities, it's going to be purified. All the Cu2 plus will oxidize. The Cu will oxidize to Cu2 plus, and the Cu2 plus will be reduced there, right? Will be reduced there, right? Which is sorry, there's a reduction that occurs here, and there's an oxidation that occurs in an anode, right? 9.1, it says, is electrode A positive or negative? Electrode A is negative, so the answer there is negative. I underlined it. The answer is negative. Now it says, give a reason for a need to refine copper before using for electrical conductivity to improve the quality of conductivity. The reason the copper needs to be purified, it's improving the quality of conductivity. Now it says, will the mass of electrode B increase or decrease when the cell is operating? Where is B? B is an anode. Always in the purification, the mass of an anode decrease. So the answer there is decrease. Now it says, write down relevant half reaction to support your answer. What is happening here? It's a Cu is oxidized to Cu2 plus and 2 electrons. So that's what is happening in that anode there in the impure sample, right? It says, after all the copper was purified, it is found that 2 mole of electrons were transferred from an anode to cathode. Calculate the mass of the impure sample. Okay, so this 2 mole, we're given the 2 mole, which is the 2 mole of electrons. So the 2 mole of electrons of copper, this is the 2 mole electrons of copper. So which is, it's 2 mole electron. So when we wanted the mass of the impure, which is the mass of this, but we were told the copper that is pure is 97. So 97% is the pure copper that is this impure sample. So what are we going to do? Normally we used to say number of electrons. When we used to say, this is the reverse kinda, number of electrons of Cu is equal to number of moles of copper times by the number of electrons, right? So now we do have this, the 2 mole of electron. Okay, let me just put 2, it's 2, and we wanted the number of mole of copper, and then we times by what? 2. because there are 2 electrons there. So we'll divide by 2, we'll divide by 2. Therefore, the number of moles of copper is what? Is 1 mole. And then we can change that into mass. We'll say number of moles is equal to mass over molar mass, which is the number of moles is 1, and the mass is the one that we're looking for, and the molar mass of copper is 63.5, and therefore the mass of copper, which is the pure one, the one that was purified or was refined, is 63.5 grams, right? So is the one that is going to be deposited here. This is the one that is going to be deposited here. All right, so now we wanted the mass of the impure. We go to the formula of the percentage purity. We'll say percentage purity is equal to mass of the pure divided by the mass of the impure multiplied by 100, right? So what we do there, we substitute what we have. We substitute our percentage there is 95.7, and we divide it by 100 since we don't want a percentage. And then the mass of the pure is the one that we just calculated, which is 63.5, and then we divide by the unknown, right? Divide by the unknown. So when you do your method there, you cross multiply, and so the mass of the impure, it's going to be the 63.5 times 100 divided by 95.7 is going to be 66.35. It's going to be 66.35 grams. That is the mass of this impure. Initially it was 66.35 grams. I hope that makes sense. Cheers. Bye.